Okay, so again, looking at the bond energy calculations 2 worksheet, I'm going to walk you through how to do question number 2. This is a little bit trickier than question number 1 because there are more bonds to think about. There's a lot more numbers in there, but if you're stuck, this is how you would go about answering this particular question. So once again, we're going to start by drawing out the molecule that we've got in the question. Be careful when doing this because when I've done this in the classroom, the most common reason why people aren't getting the correct answer each time is because they haven't accurately copied out the question. Sometimes they start reading question number 2 and their eyes go down the page and copy out the second half of question number 3 and so on. So just be careful with that. Let's get rid of these splodges from my hand. Okay, so we've drawn out the molecule here, and we are going to again divide it in 2, and we're going to count up the bonds that we have got and each of the different types of bonds. So on the left hand side, the first bond I can see that we've got here is a C to H bond. Now I can see that I've got 1, 2, 3, 4 of this type of bond. So looking at the table, the CH bond value is 412, and I'll come back to doing the maths in a second. Okay, another type of bond that I've got here is this C double bond C. Just got one of these. Be careful in the table, the C double bond C is different to the C single bond. So this one has a value of 612. And then I've got the OO bond here, but don't forget there's 3 of this molecule, which means you've actually got this going on here. So there's 1, 2, 3 of these. And the O double bond O value is 498, 3 lots of 498. So let's add all of this up on this side. 4 times 412 gives us 1,648. 612 times 1 is easy. And 3 times 498 gives us 1,494. Then we need to add these numbers together. So adding all of those up on the calculator is going to give you a value of 3,754. Remember, that is the amount of energy that is required to be taken in order to break the bonds. So let's move to the other side. Again, we've got some 2's here in front of each of the molecules, so I would simply get rid of those 2's and draw the molecule out again so that it's easy to visualise all the different types of bonds that you have got. There we go. Okay, so on this side you can see that we have got a C double bond O bond here, and we have got 1, 2, 3, 4 of those particular type of bonds. And each C double bond O is worth 743. Okay, and then we have also got the OH bond here, and again we've got 1, 2, 3, 4 of the OH bond. And the OH bond is worth 463. So we multiply these up, so the 4 times the 743 gives us 2972, and the 4 times the 463 gives us 1852. We add these 2 values together. 2972 plus the other one is 4824, and that is the amount of energy that is given out when we make these bonds. So like before, we work out the overall energy change, and it is the amount of energy required to break the bonds, take away the amount of energy to make. So the left take away the right. 3754 minus 4824, and that gives you a value of minus 1070 Again, that is in kilojoules per mole. If you get into a good habit of drawing out these diagrams each time you do a question, you'll get into a good sort of flow, and you'll be able to easily track back and spot mistakes that you make, such as not properly counting the number of bonds. If you make sure you cross off the bonds each time you do this, you'll be able to spot if you've not taken a bond into an account at any point. Also, in an exam question, it allows the examiner to see your flow of thinking. So if you do make a silly mistake, they'll be able to award marks to you if you type things into the calculator, which is easily done when you are under pressure in an exam. So as before, this is a minus number overall, which means this reaction is also exothermic. And so this energy diagram, like the one before, would look like this, because the value here is smaller than the value here on this side, so that energy is going to come out negative overall.